Hey everyone, welcome back to GSC, Go Science Crazy. My name is Jacob, and today I'm going to be walking you through how to use your lamp circuit board to build simple parallel, series, and combination circuits so that you can better visualize and grasp some of the basic concepts of electricity. Before we begin, it's important to have a basic idea of how electricity works. The three most important terms to understand about electricity are voltage, current, and resistance. Voltage is the difference in charge between 2 points. It can be thought of as electrical pressure. Current is the rate at which charges flow within an electrical circuit. And lastly, resistance is a material's tendency to oppose the flow of current through it. To better grasp these terms, a lot of people like to use an analogy comparing how electricity behaves in an electrical circuit to how water behaves in an enclosed plumbing system. Let me explain. In a circuit, voltage supplied by the battery is comparable to water pressure supplied by a pump. Current, on the other hand, is similar to the flow rate of water as it passes through the pipes. And lastly, to wrap up our analogy, resistance, like in the amounts found in a resistor in our circuit, is similar to the way water acts in a pipe if the pipe were to suddenly narrow. Voltage, current, and resistance are all mathematically tied together using Ohm's law. While this experiment is primarily designed as an aid for visually understanding circuits, this formula is essential if you want to be specific about the behavior of electricity in the circuits you build. Once you've experimented as far as you can with this lamp board, I suggest that you invest in a multimeter to take electrical measurements throughout your circuit. With this, you can diagram each circuit you create, solve for the electrical values within it, and then double check your work with the meter. There is no shortage of tutorials online walking you through the basic math of circuits. So, if this interests you, I suggest you dig deeper into Ohm's law on your own next. Lastly, let's quickly talk about what type of circuits we're going to be working with. When items in a circuit are linked end to end in a single line, they form a series circuit. In circuits like these, current flows in a single shared path. Voltage from the power supply is divided across each resistor, and the resistance totals for the circuit is the sum of the individual resistance from each resistor. When items in a circuit are connected to the power supply along separate branching paths, they form a parallel circuit. In parallel circuits, the current is divided up across each branching path, each resistor in the circuit receives the same voltage, and the resistance values of the resistors are tallied up by adding their reciprocal values and taking the reciprocal of their sum, meaning that the total resistance of the whole circuit will be less than the value of the smallest resistor. And finally, series and parallel elements can be combined within the same circuit. Its electrical characteristics are calculated by solving the parallel and series elements separately before adding them together. Depending on their build, combination circuits can vary by a lot. If you do look into Ohm's law like I mentioned earlier, diagramming and solving for the values inside combination circuits is where you will really hone your math skills when dealing with circuits. Your lamp board consists of 5 sockets fixed to a sturdy plastic base with rubber feet. There are 2 bus bars between each socket, which you will use to create your circuits. They can be adjusted by tightening and loosening the knobs adjacent to each socket. Your board also comes with 5 mini lamp bulbs. These bulbs are rated at 2.5 volts and come with an E10 style base. While even proper use will eventually wear out the filaments in your bulbs, the nature of this experiment puts extra strain on them by switching them on and off repeatedly and by sometimes supplying more voltage to them than they are designed for. When this happens, don't worry. Just look for 2.5 volt bulbs on an E10 base. My replacement bulbs were rated for 1.25 watts of power and they worked great. To use your lamp board, you're also going to have to gather a few extra supplies. First, you need at least 2 lead cords with alligator clips. You are also going to need a 6 volt power supply, which will ideally consist of 4 AA batteries linked together in series. This supply will work well for most situations on this board, but stick around for a small note on choosing your power supply in just a second. Once you've gathered these supplies, attach your lead cords to your power supply, and you're ready to start making circuits. As I mentioned a second ago, there's a bit more that goes into choosing your power supply. Your bulbs require 2.5 volts from your power supply to produce light. If they receive too little voltage, they will be dim or not light up at all, and if they receive too much voltage, the filament will overheat and break. In fact, 6 volts from 4 AA's is almost enough to burn out your bulb if it is alone in the circuit. Watch how the same 6 volts from 4 D cells behave instead. Because D cells are larger batteries, they have less internal resistance, allowing them to produce just enough extra current in your filament to break it. Likewise, Watch how 9 volts also breaks your bulb. So while we have a few broken bulbs laying around, let's compare how they act in a series circuit to how they act in a parallel circuit. This could help you in the future if you need to troubleshoot a circuit you create by looking for breaks. Notice in this series circuit how the broken bulb stops the electricity in its tracks. With the filament in the bulb broken, the circuit can't complete itself and no electricity can flow through any components in it at all. Now watch how the broken bulb works in the parallel circuit. Because of the branching paths of a parallel circuit, the electricity can still flow through all other parts within it. Now that we're ready, let's begin building our circuits. We'll start off looking at the series circuit. Here, I start off by creating the largest possible series circuit on this board, and I gradually reduce the number of the circuit by one bulb at a time. Notice that the bulbs get brighter as the circuit gets smaller. This is because voltage is divided among each resistor within the circuit. Since the bulbs all share the same resistance values, the voltage of the supply is evenly divided across each bulb. Now let's take a look at the same thing from a different angle. While observing your series circuits, remember that the current follows a single path and is shared across all elements of the circuit. Next, let's take a look at parallel circuits. Just as I did with the series circuit, here I am starting with the largest possible parallel circuit on this board. As you move from the 5 bulb parallel circuit down to the smaller circuits, detach your alligator clips while making each adjustment and be sure that your bus bars remain tightly fastened. As opposed to the series circuit in which every element shares a common current and the voltage is divided across each resistor, parallel circuits work almost the opposite. The current is divided across each branching path on the circuit, but the voltage remains the same throughout every element connected in parallel. Think back to our circuits with the broken bulbs in them. This branching current in the parallel circuit is the reason that the working bulbs in the circuit continued to shine even with the broken bulb in place. Finally, let's look at some circuits that contain elements of both series and parallel circuits. This circuit right here contains 2 separate 2-bulb parallel circuits connected in series with a single bulb. Here's a side view of the same circuit in case the bulbs connected in parallel were too dim to see light up. Now, let's look at a similar circuit, but this time removing the bulb connected in series. Notice how much brighter the parallel resistors are without the series bulb present. Lastly, let's check out one more example. Here you see a single bulb in series connected to a 4-bulb parallel circuit. Notice that only the single series bulb lights. This is due to the insufficient voltage of the power supply for this circuit. And that's all for today. I hope you walk away from this video with a little bit of a better understanding of how circuits and electricity function. For more science projects and experiments, visit us on our website at www.gosciencecrazy.com. Till next time, take care, be safe, have fun, and go science crazy.